Hello, we're here to do a water quality demonstration. We're out here in Seminole State Forest, just north of Highway 46, State Road 46 in Lake County. And behind me is Blackwater Creek that flows from here to the Wekiva River, which is just east of here a couple of miles. And so what we're going to do, I'm going to show you some equipment that we use, and I'm going to show you how we collect a sample. And you probably notice I wear gloves, and that is both to protect me, although I think this water is pretty clean, but it's also to protect the integrity of the water sample. So the first thing that I have are a couple of instruments that basically do the same thing. They measure pH, and remember pH is the the negative log of the hydrogen ion activity in the water. So pH 7 is neutral, pH less than 7 is acidic, pH greater than 7 is basic, you know. And then the other thing we're testing is what we call specific conductance, which is the ability of the water to transmit electricity, and that's related to the amount of dissolved ions in the water. So the more salts you have in the water, the higher the specific conductance is going to be, okay? And so we're measuring both of those things. I have two instruments that do the same thing. So this first one is an older model, and it's measuring a pH. Here, I'll bring it up and show you the probe. So we can see the probe there, which measures temperature, it measures specific conductance, and it measures pH. The pH is the little glass bulb right there in the center. And it's measuring a pH, and that's the instrument there, okay? And that's showing pH right now, although it's out of water, so it's not accurate. And if you hit the mode button here, it toggles to specific conductance, okay? And I'll put it in the water so we can get a reading. We're hearing all kinds of splashes in the water, by the way. So there's fish or alligators or something jumping around. And so I don't know if you can see that from back there, but it reads a specific conductance of about 335. I'm going to toggle again. And it's reading a pH of 6.74. Remember, the pH scale is a log scale, so pH 6 is going to be 10 times more acidic than pH 7. So slight differences in the pH scale make a big difference in the actual hydrogen ion activity. This is a newer version, same kind of instrument, but this one's better. This is a nicer quality. So here we can see we got a bigger, heavier, more robust probe. And then we've got our instrument that actually, our display that actually measures it. Okay? And I'll put the probe in the water and see how the two instruments compare. The cheap one, and it's not cheap, by the way. It's just less expensive. So this one is reading a specific conductance of 337. The other one was 335. So that's really close. That's really good. And the pH is 6.80. I think the other one was 6.74, we said. So again, very close. Oh, this one's dropping down a little bit. pH of 6.79 now. I can't get too much closer. Awesome. All right. Now, the one last thing I want to show you is how we actually take a sample. And this is not really the proper way if you worked for the U.S. Geological Survey or the Department of Environmental Protection or something. Their standards are a lot more rigorous. But this is just something I picked up for classes. And this is called a baler, okay? So it's basically just a tube that's open on both ends, a plastic tube in that case. And it's got what we call a little ball check valve at the bottom here. There's a little ball. Might be able to hear it rolling. Okay, so as I drop this baler into the river, that ball is going to open up and it's going to allow water to pour in from the bottom of the baler. But the minute I start pulling the baler up, that ball is going to seat itself at the bottom. It's going to shut off the water, and I'll be able to pull up a sample. And they call this stream, they call it Blackwater Creek because it's very dark in color. It's got a lot of what we call tannins in it that result from the decay of vegetation. So it's literally tea-colored water. My baler is not sinking because the stream flow is too strong. But I think I've got enough. I only need 10 milliliters of water, which is not very much, okay? And in water quality, we really want to rinse everything. We really want to rinse everything like 3 times, okay? So I'm going to rinse this out. And you might be able to see now how tea-colored it is. So that's probably going to affect, I know it's going to affect my, my analysis. We'll try again. So the type of analysis I'm going to do is called a colorimetric analysis. And it's going to analyze nitrate in the water, which, if you remember right, nitrate is one of the nutrients that we talked about that is, it's naturally occurring, but it, high concentrations can come from fertilizer, animal waste, human waste, stuff like that. And high levels of nitrate in the water will cause methemoglobinemia in babies, and it also causes excessive algae growth. So what I have here now is a little ampule here that contains what we call a reagent. Okay, so it's a little white powder in the bottom there, and what I'm going to do is, this thing is in a vacuum right now, so I'm going to hold it under water. It's going to break the top off, and that's going to allow exactly 10 milliliters of water to be sucked up into here. Okay. Okay. So now what do? Is I shake it for, I think it's like 2 minutes, and I didn't bring a watch or anything, and I shouldn't, there's a little rubber stopper. Oh, now don't worry about it. All right, so we're just going to pretend that I shake it for 2 minutes. And the more nitrate in there, the more amber it's going to turn, okay? I really don't expect much nitrate to be in this stream, but as you can see, it's already kind of amber colored because of the tannins in the water. So that's going to interfere with our analysis. We're not going to be able to get a good analysis because of that. We just want to make sure all the powder is dissolved. And this has cadmium in it, and so we won't be able to just throw that away or dump it out, because that's would be considered a hazardous waste. So I guess I'll just have to wait until I get back to campus and dump it out or something. So, and now this is a Hawk. Hawk is the brand colorimeter, okay? And I've got to turn it on. I had it on. It's supposed to warm up for like 15 minutes. I've had it on for at least 15 minutes here. And so when that thing reacts, when that water reacts with the reagent in that ampule, what we do is we put it inside. There's a little hole here that fits that ampule perfectly. And I got to make sure it's all dried off, and I should have brought some like tissues to wipe this off with, because this is optical glass, so you don't want, so scratches will mess it up, but hopefully my shirt is soft. Okay, and what we do is we put the ampule inside there. We don't want any light getting into there, so we put the top on, and then we hit, okay, so I put my ampule in, and then I put my little cap over it to block out the light, and what there is there's a little beam of light with a specific wavelength that shoots through that ampule. And if it reacts and the water turns amber, that interferes with the light shooting through the ampule, and then there's a little sensor in there that picks up the light. So the less light that interacts with the sample, with the sensor, the more nitrate there is in the sample. Okay, so what do is I hit read, and it's reading 1.1 milligrams per liter. Okay, again, I think that's probably not a terribly accurate measurement, because of the color of the water is already making it look amber colored. That same kind of color that you get from the what am I saying? The same kind of color you get from the reaction. So all right. And I don't have any other water to test to show you that would react and do it. And while we're at it, I don't know if you can see it. Can they see the gauge from where the camera is set up? No. Yeah. Okay. And then one last thing I wanted to point out is that this is a gauging station. So there's an instrument in there, probably something we call a pressure transducer, which is an instrument that measures water pressure. And what it's basically doing is measuring how high the water is in the stream. And the higher the water is, the bigger the discharge is going to be. Usually they have like charts with what we call gauge height plotted against discharge. And so, but there's automatic calculations that do that, and as you can see, this has a satellite antenna. I don't know if you can get it in there, and it's also got solar, and so basically that's probably providing a live feed to the St. Johns River Water Management District. And so this is again called Blackwater Creek. So you can probably look it up on their website, which I believe is sjrwmd.com, I think, and be able to look that up and be able to get the discharge for today at whenever time it is, 3 o'clock. Okay? All right, well, thank you very much. I hope you enjoyed the video, and I will talk to you later. Bye.